Hello everybody and welcome to the first Maths with Harry lesson. In this video we're going to be learning all about index laws. We're going to start by looking at a little bit of notation. You've probably seen this at GCSE before, you might not have done though, so we need to make this clear because I'm going to be using this language throughout the whole of this course really. So I'm going to do a little bit of notation in the corner here and I'm just going to see if I can draw some boxes. Perfect. So, you might already see what I'm about to do, I really don't know, but I need to introduce some notation, and I'm going to do this using the example 2 cubed. Okay, now you probably know that 2 cubed is 2 times 2 times 2. All we do is we take the number on the bottom here and we multiply it by itself as many times as the little number says. Alright? So 2 cubed, or 2 times 2 times 2, well, 2 times 2 is 4, and then times by 2 gives us 8. So 2 cubed is 8. Now, what I need to do is introduce a little bit of notation. And throughout this video, I'm going to be calling this number here, that's the bigger number, in the bigger box, kind of on the floor, if you like, if you class this line as the floor. The big number is called the base. You probably heard this before, but if you haven't, then we call the big number the base number. The number that we raise, that's here, this little number, we raise the base to this number. We call this the power, or sometimes they are called the index, and that's why they're called index laws, or sometimes they're called the exponent. So there's just 3 names for them. I will either call it the power, and most often I'll call it the power. Sometimes I might call it the index. And then this number here really is my answer. It's what we get from raising our base to the power. So that's a little bit of notation. And if we wanted to write that out, we could say we have a base, we raise it to a power, and we get an answer. Alright, so let me make a little list of the things that we're going to be learning in this video. We're going to be having a look at index laws, we're going to have a look at some examples, we're then going to have a look at negative powers, and we'll do some more examples. We'll also have a look at some rules that come under index laws. They're not really rules, laws are things that you have to learn, the rules are things that you just kind of want to be aware of, things that are really, really helpful. Okay, so let's have a look at the 4 laws. Now, if you're following along with the Edexcel book, we're on page 2. The 4 laws are as follows. There are 4, so we'll list them 1, 2, 3, 4. And the first one is when we're multiplying powers. So if I have some base, we'll call that A, and I raise it to the power n, and we multiply that by the base a, raised to the power m. Notice how I'm now using this notation, or this language. We've got the base a, and notice here, these 2 bases have to be the same. So they both have to be 2, they both have to be 7. They both have to be the same. 2 and 7 were just examples there. When we have that, what we can do is we can simplify, we can bring them into one base, and we can collect the powers by adding them together. So we can just multiply, and when we multiply, we add the powers. Okay, so the base stays the same because the base is just A, and we multiply the powers. Let's just have a quick example where we've got that first rule. Let's say we've got the base 2 and we raise that to the power of 4. And let's say we multiply that by 2 squared, or 2 to the power of 2. Well, note that the bases are the same, so the base is going to stay the same. And then the powers, all we're going to do with the power, and I'll actually highlight that in red, is using the rule, we're just going to add the powers together. So when we do that, we're just going to get 2 to the power 6. And then all that means is 2 times 2 times 2 times 2 times 2 times 2, times in 2 by itself 6 times. You could work that out if you wanted to. We could say 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we can say that 2 to the 6 is 64. Or 2 to the power 4 times 2 to the power 2 is 64. Alright, so there's just a quick example of that rule. I'm going to rub that out so that we can get some more rules down. Now we've got a rule for when we multiply the powers, so we are of course going to have a rule for when we are dividing. And when we divide, let's say we've got a to the n divided by a to the m. Notice what's different here. Here we were multiplying, now we are dividing. What we do is we subtract the powers. So all we do is when we divide two things and they both have the same base, we can collect the powers together. When we divide, we just subtract the powers. And notice the order that I subtract. We can see I've got the n first, so I do the n first here. And we're dividing by a to the m, so I subtract the power of m there. The second law is when we've got a power to a power. So let's say we had a to the n, and I'm introducing brackets here because if you look, I'm going to raise all of that to the power m. So what I'm doing here is I'm actually doing a to the n, working out what that is, and then I'm going to raise that all to the power of m. To simplify that up, all I can do is take the two powers and just multiply them together. A to the n multiplied by m. And remember, I'll put that in grey. That's actually equal to a to the n times n. If you remember from GCSE, AB is the same as a times b. We just don't bother writing down the times. Okay? Let's have a look at the fourth rule. And the fourth rule is when we've got two things in our base and we're raising those two letters, in this case, which are actually numbers when we substitute. But let's say we had a and b. We were raising both of those to the power n. How can we do that? Well, let's have a think. What we're actually doing is we're multiplying a and b together and then getting an answer and then raising that to the power n. Another way we could do that, it depends on the numbers whether it's more simple or not really, but another way we can do that to expand is say a to the n multiplied by b to the n. What we can do is, I'm going to use the word distribute here, I can distribute the n and raise the a to the power n and multiply when I distribute the b to the power n to get a to the m times b to the n. So those are my four rules, and I'll give those a little border in red. Perfect. Those are the four laws. Sometimes they are called rules. Some other rules as well that I want to have a look at is just some simple things that you might need, well, you will need to know, but you might already know them. So let's just get rid of that, and let's just have a look at two simple rules here. Now it's a bit obvious and you might know them, but if we take a can be anything we like. A is a variable here, so we're going to substitute numbers in. It works for any number. If we raise a to the power 1, so we've got a to the power of 1, here our base is a and our power is 1. When we do that, we are going to get a. Anything to the power 1 just gives itself. So for example, if we had, I don't know, 16,000, there we go, that's 16,000, and we raise that, let's put brackets, and we raise it to the power of 1, that's just going to give me 16,000. If I had 1 million, and I raise that to the power of 1, that's just going to give me 1 million, because raising anything to the power of 1 doesn't change what the base is. Let's have a look at another rule, or I class it as a rule anyway. What you will need to know is that if I raise a to the power 0, what does that give me? Well, it's just a rule that you need to know. You can kind of prove it in a way looking at powers. There's lots of videos online if you want to look at that. But a to the power 0 always gives me 1. And in kind of English words here, anything to the power 0 will give me 1. So I can put anything as a, raise it to the power 0, it will give me 1. So those are just two simple rules that you will probably want to be aware of. Alright, I'm going to have a look now at some examples. Feel free to pause the video and have a go at them, and then play them when you're ready, or if you don't want to pause, we'll work through them right now. If you did pause, hopefully you had a go. Let's have a think. So we have 4 laws, and the 4 laws are on the screen here. So let's have a look at A. We can see that we've got x squared and x to the 5, and what we're doing is we're multiplying those together. Now notice, it's really important at A level that you distinguish between what is your multiplication sign and what is your algebra x. So I always use a multiplication sign as a straight x, and then my algebra x as a variable, I use it as a curly x. So what this example here is saying is x squared times x to the 5. For this example, we can first use the first rule because we're multiplying two things together that have the same base, and I'll do my answers in blue. We can write that as x, and then we're going to add the powers. And that will give me x to the 7. Because all we're doing is multiplying, and when we multiply, we add the powers, and the base stays the same. Good. Alright, let's have a look at B. For B here, we are, again, doing the same thing. We are multiplying, but you might think the bases are different. Well, actually, the bases are not different. If I wrote this like this, 2 times b to the 4 times b to the 10, I'm sure you would be able to tackle this problem. What we can do is we can first off do that bit in red. We can say, well, we can use the law 1 here. We can use the first law to say that's 2 times b, and I'm going to go straight to the 14 there by adding the 4 and the 10. And when we do that, we get 2 times b to the 14. Now, I can't bring those together any other way than I kind of already have done. All I can do is just get rid of that multiplication sign, because the base is not the same, so I can't do anything and add the powers. That doesn't work. I can just get rid of the multiplication sign and say there I have got 2b to the 14. And I'll highlight my answers in yellow in case you want to pause the video and find the answers. So 2b to the 14 is what we should have got for B. Let's have a look at C. C, we've got 6x to the 5 divided by 2 to the minus 3. Now, we actually haven't had a look at negative powers, so don't worry if you weren't too sure on this. You probably have seen negative powers before. We're going to get onto those in a minute and look at fractional powers as well. But let's say we have seen negative powers, because you probably have seen them at GCSE. Let's have a think how we could have tackled this question. So, again, we're looking at the bases. If I highlight the bases here in red, we can see there's my base 2, and my base is 6x. But actually, the 5 does not belong to the 6, because remember, if I just get rid of the highlight, what I can do is I can say that's the same as 6 times x to the 5, and then all divided by 2 to the minus 3. Okay? So what we need to first do is somehow simplify this 2 to the minus 3. And I could possibly write this down. So, in fact, we'll add that as a rule because it's in the example. Let's add that as a rule. So go back to your rules if you're making some notes. Let's add it as a rule. If we've got a to the minus n, what we do is we say, well, let's get rid of the negative and let's do the reciprocal, because that's what that means. The reciprocal is when we flip what we've got. Now notice, a to the minus n is actually divided by 1. We just don't need to divide by 1. We never write that. So the reciprocal is we flip that over. We say 1 divided by a to the n. What we do when we take the negative power is write 1 over the positive power. And I'm just going to get rid of that grey one now. Alright, so that's another rule. So I suppose we should have really had that at the start, but if you knew it at GCSE, then you would have been able to do C. So, using that rule, if you like, what we can do is we can write this as 6 times x to the 5. And then, well, we're going to divide, and I'm actually going to write that over 2 to the minus 3. We will then have that as 6 times x to the 5 divided by, and we don't really need to write it as a fraction. I could write it again as divided by, and I'm going to divide by 1 over 2 to the 3. So just note I wrote that as a fraction because that's equivalent to that, and then it might be easier for you to think about it like this, and we could just move that down. Alright, so what we're doing is we're doing 6 times x to the 5, and then we're dividing that by 1 over 2 to the 3. But I can actually replace 2 to the 3 by 8, because we know what 2 to the power of 3 is. And then if you remember from GCSE, when we divide by a fraction, we actually multiply and we flip the fraction. So I might just be able to squeeze this on at the bottom here. We've got 6 times x to the 5, and then we'll multiply by 8, because we just flip the fraction. If you remember KFC from school, you might have done. All right. Now, we can't really do anything with the x to the 5. That's just going to stay there exactly the same. But what we can do is we can multiply the 6 and we can multiply the 8. Just like we usually do. 6 times 8, we can simplify. And when we do simplify that, 6 times 8 will give us 48. And then we're going to have multiply x to the 5. Alright, well, like we had here, we don't need that multiply symbol, so we can just get rid of it and say that's 48x to the 5. That was a little bit of a tricky example because I didn't mention the negative rule at the start, but you probably had seen it at GCSE before, so hopefully you gave it a go. So that is your answer, 48x to the 5. Alright, let's have a go at D. So for D, what we needed to do is we needed to use this third rule here to simplify these brackets. So when we do that, what we will get is, well, we're going to multiply the powers, and I'm just going to use a blue colour here. We'll multiply the powers using the third rule. So we'll get a to the 2 times 3. Multiplied by a to the 8. I've just simplified that bracket and then multiplied by a to the 8 there. So then what we can do is we can simplify the 2 times 3. So when we do that, we will get a to the 6 multiplied by a to the 8. And then we can use rule 1 to simplify this even further. Using rule 1, what we will get is we will be able to add the powers together because both of the bases are a. So when we do that, we will get a to the 6 plus 8, which will give us a to the 14. That's your answer for D. Let's have a look at the final 4 examples here. If we were to do E, well, the first thing you needed to do was simplify this bracket here. So we can use the third rule here. I'm going to speed up a little bit because hopefully you're getting the gist of this now. Using the third rule, that will give us r to the 40. We'll just multiply the 4 and the 10. And then we can't really do anything with that 2, so I'm going to write that times 2. I'm also going to write that 2 times r to the 6. And then I'm going to multiply, and look here. We've not seen this before in this video. What we're doing is we're doing the 2 to everything inside those brackets. So what we need to do is distribute, and we're using the fourth rule here, we've got A to be 4 and we've got B to be R. We need to distribute the power over the 4 and the R. So if I draw little arrows in here, I need to distribute that 2 to the 4 and distribute it to the R. So that will give me multiplied by 4 squared times R squared. Simplify that, I'll have R to the 40 times 2 times R to the 6 times 4 squared, that's 4 times 4 is 16, and then times R squared. And then I'm going to, if I highlight in red, the 2 and the 16, I can just multiply those together, and then I can add all of those green powers. So that will give me 2 times 16, which is 32, and then the powers will give me 40 plus 6 plus 2, which will give me 32r to the 48. And that is your final answer for E. Alright, let's have a look at F. So for F, what we were doing is, well, let's have a think. We're dividing. So if we just highlight there, we're dividing, but we've not got the same base. So we can't really do anything apart from just simplify the numbers. We can't do anything with the x to the 12s because we can't combine those powers together. But what might help you with this is if we think about what we get if we write this as a fraction. So if I write 121x to the 12 on the top, and I divide that by 22x to the 12 on the bottom. Like I've said in this video, another way of writing that is 121 times x to the 12. We just don't need the invisible multiplication sign. And then 22 times x to the 12 on the bottom. On top and bottom, we both have here x to the 12, and on the bottom, x to the 12. So if you remember from maybe algebraic fractions or what you've done at GCSE, we can simplify and divide by x to the 12 on top and bottom. They'll cancel each other out. And then all we're left with is the numbers. So we couldn't really simplify the powers, but actually they disappear once we think about what we're actually doing. And then both of those go into 11, so we can divide both of those numbers by 11 to give me, well, 121 is 11 times 11, so 11, and then 22 divided by 11 is 2. So you could leave it as a fraction like that, or you could say that is 5.5. Either way, that is a correct answer. So that was a little bit of a trick one, really. We didn't really have to do any manipulation with the powers. All right, let's have a look at the final two examples. All we're doing here is, well, we've got a division and a multiplication. So we need to think about BIDMAS here. So let's have a think about BIDMAS, and this might make it a little bit easier. You've probably seen BIDMAS before. It's the operation, or the order of operation that we do everything. So we have B for brackets, I for index, D for division, multiplication, addition, and subtraction. So the first thing that I can see here is that we've got a division. So I'm going to do that division first. When we do that division, well, I'm thinking if I maybe put brackets round that bit, that's the bit that we're going to do first. I'm going to take those brackets off because it wasn't the original question. But let's think. What we're doing is we're doing the second rule here. We're dividing two things that have the same base, so we can just subtract the powers. So when we subtract the powers, we will have p to the 2 minus 5, not the other way around, 2 minus 5, then multiplied by p to the 20. We can simplify the power there to give me p to the minus 3, multiplied by p to the 20. And then all I'm going to do is, because we are multiplying, I'm just going to add the powers together. So when I do that, that will give me p to the 17, and that is your final answer. Okay, let's have a think about the last one. Here we have 3 things in our bracket, and we're raising all of those 3 things to the power 4. So what we can do is, it doesn't matter how many things we've got in this bracket here. In our example here, we had the 4 and the r, we had 2 things. Here, all we've got is 3 things. So I'm just going to do the exact same thing. I'm going to distribute, to the x, I'm going to distribute to the y, and I'm going to distribute to the z. So let's do that. We will have x to the 4 multiplied by y squared, and I'm going to put brackets to the 4, multiplied by z cubed to the 4. And then we can use this rule here, this one here, the third one, with this and this, to then merge these powers together. And to merge them together, we're just going to multiply, because it is a power on a power. So let's have x to the 4 multiplied by y to the 2 times 4, which will give me 8, multiplied by z to the 3 times 4, which will give me 12. Now, nowhere in this example did I specify that x and y and z were the same. They are different letters, different variables, so we can't do anything with that. The only thing we can do is get rid of the multiplication sign. So x to the 4, y to the 8, and z to the 12. All right. Here is when I actually introduced the negative power. So we did have a little sneaky example here that cropped in, but we'll look at negative powers very quickly now. So negative powers, like I said, we have a to the minus m. We write that as 1 over a to the positive power. So this might be quite easy for you to have a go at now, but pause and have a go if you want to, and we'll very quickly work through the answer. All right, hopefully you paused and had a go. All we need to do here is we need to write all of these examples with 1 over p to the positive power. So we just get rid of the negative and write it 1 over. So p to the minus 1, well, that will give me, and I'll do my answers in blue again, 1 over p to the 1. But remember the rule I mentioned up here, anything to the power 1 is just itself. So yes, this example is correct, but I don't need that power of 1. So that's just going to be 1 over p. Having a look at the next example, p to the minus 2 will be 1 over p squared. And then p squared, well, can I do anything with that? Actually, no, I can't, because I don't know what p is. P squared is just p squared for the minute. So that will be my final answer, and I'll highlight both of those. P to the minus 3 is going to be 1 over p to the positive power, which is p cubed. And I can't do anything with that, just like I couldn't do anything with the p squared. So we'll leave that to be my final answer. Let's have a look at the next 3. So we've got p to the power of minus a half. I haven't introduced fractional powers yet, that will come in another video, but we just do the exact same thing. I just take 1 over p to the positive power, and I could write that as a decimal if I wanted to, so that's 1 over p to the half. Both of those are correct. Alright, let's have a look at the next one. These are going to be quite simple. We should have had 1 over p to the 10, and then 1 over p to the power 3, or p cubed. And actually, we've already done that example. Those are exactly the same, which you didn't realise. Alright, so those are negative powers. There's not really much else to say, but let's finish off with this example. What I want to do is I want to calculate p to the minus 2 when p is equal to 2, so when our base is 2, because remember, this p is our base, and this minus 2 is our power, or index, or exponent, we'll call it a power. So what we need to do is we need to kind of substitute p as 2, p as 3 and p as 4 and work out what we get. And this example is a little bit more real life, if you like, because in exams, yes, you might be asked to simplify this. At A-level, it probably won't be a single question. It will be in a big question, but you are more likely to have actual numbers involved. So what we're going to do is we're going to take p to be 2. So p to the minus 2, when p is 2, will be 2 to the minus 2. And remember, I can write that as 1 over 2 to the positive power. And then I can simplify 2 squared because I know what 2 squared is. That's 1 over 4. So when p is 2 in this example, I get a quarter, or 1 over 4. Let's have a look at when p is 3. So p to the minus 2 will be 3 to the minus 2 when p is 3. And that's then going to be 1 over 3 to the power 2, or 3 squared, which will give me 1 over 9, because 3 squared is just 3 times 3. You can see the pattern that we've got going on here. P to the minus 2 when p is 4 will give me 4 to the minus 2. And then I can have that as 1 over 4 squared. Just write that a little bit neater. 4 squared. And 4 squared we know is 16. So we can write that as 1 over 16. And that is everything that I've got for this video. I'm just going to check that I covered everything in the book that I needed to cover. Yes, I did. So in the next video, if you're following these in chronological order, we'll have a look at fractional indices.